Hey students, in this clip we're going to be going over an example on how to multiply rational expressions. So let's go ahead and take a look at the example. So the task is to simplify this rational expression, x squared minus 2x over x squared minus 4 times x to the third plus 8, and that's binomial divided by 2x to the fourth minus 4x to the third plus 8x squared. Okay? Alright, so to multiply, what I'm going to do first is I'm going to factor the numerators on the left and the right side, and then the denominators, multiply the factored form and then see what cancels out, and that will leave me with my final result. Okay? Alright, so let's go ahead and start extracting and factoring out the different components of this product of rational expressions. So I'm going to start with the left numerator. Alright, so for that one, we have x squared minus 2x. Okay, let's decompose it to see if we can factor out the GCF. So we have x times x minus 2 times x. So what you notice here is that x is common in both terms, x and x, so we can factor that out. So we're left with x times x minus 2. Alright? So the factored form of the left numerator is x times x minus 2. Alright, now let's shift our attention to the numerator on the left side. Okay, the denominator on the left side, to the left denominator. Let's write that down. Left denominator. Okay, so for that one, the left denominator, we have the expression x squared minus 4. We can clearly see that there's no GCF to be factored out. So if you examine this, you notice this is a square, that's a minus, so we can use the difference of squares formula. Okay? And we know from that the difference of squares formula, let me just put it here, you don't have to write this down. If you have a squared minus b squared, difference of squares, you square the first and the last, and then you add and subtract the square roots, right? So the factored form of a squared minus b squared is a plus b times a minus b. All right, so we're going to apply that idea here. A squared is x squared, and then b squared is negative 4. So to factor this difference of squares, we'll root the first and the last term, and then we're going to add and subtract the square roots, okay? So the factored form is going to be x minus 2 times x plus 2. It doesn't matter the order since multiplication commutes. So we're going to have x minus 2 times x plus 2. All right, now let's shift our attention to the right numerator. The right numerator is x to the third plus 8. Okay, let's write that down. Right numerator. Alright, so what on earth is this? What is x to the third plus 8? Can we classify this binomial? Well, this is a sum of cubes, okay? Unlike squares, if it's a sum or a difference, they can be factored if they're cubes on both sides of the operation. Alright, so how do you factor a sum of cubes? Well, the formula for the sum, if you have a cubed plus b cubed, the factored form is going to be a plus b. The first sign is the same. Second sign is going to be the opposite, a squared minus ab, and the last is always positive, so plus b squared. So that goes the factored form. Alright, so all we just have to do is find a and b, and then we're going to input it into this equation right here. So how do we find a and b? To find a, what we'll do is we'll take the cube root of the first term, okay? The cube root of x to the third is x. And then to find b, we're going to take the cube root of 8, the second term, which is 2. Okay, so now we're going to plug this information into the formula. So let's rewrite the formula again. It's going to guide our the construction of our solution. A to the third plus b to the third equals a plus b times a squared minus ab plus b squared. Okay, so the original problem, a to the third is x to the third, b to the third is 8 equals a is x plus 2 times a squared is x squared. AB is the product of these two, which is 2x, plus b squared, which is 2 squared, that's 4. Okay, so this is the factored form of the right numerator. Okay, so we're going to insert this factored form into our original problem. Okay, so let's go ahead and do that. So it's going to be x plus 2 times x squared minus 2x plus 4. Okay, now finally let's shift our attention to the denominator on the right, the right's denominator. Okay, we can do that right here. I think we have enough space. So right, wait, hold on, let's see. Okay, right denominator. All right, so the right denominator, we have the expression, let's see what it is again. Okay, I got it. Okay, so it's 2x to the 4th minus 4x to the 3rd plus 8x squared. Okay, so to do this, let's first of all see if we can extract the GCF. We're going to decompose everything. So we have 2 times 1, 2, 3, 4. 2 times x to the 4th. 4 can be decomposed into 2 times 2. And then x to the 3rd is x times x. Plus 8 can be decomposed into 2 times 2 times 2 times x times x. Okay? Alright, so what can we extract from this decomposition of the three terms? We have a 2 in common from all three. And then we can also extract two x's, x times x, and then x times x. Alright, so that yields 2x squared on the outside, and on the inside we're left with x squared minus 2x plus 4. Okay? Okay, let's make the x game and see if we can factor this trinomial, this quadratic trinomial on the inside, alright? So AC is 4, and B is negative 2. Alright, so what two numbers multiply to give you 4 and add to give you negative 2? Let's look at the factors of 4. For 4 we have 1 times 4 is 4. This yields 3 or 5. And then 2 times 2 is 4. This yields 0 or 4. So none of the pairs of integers that yield 4 add or subtract to give you negative 2. So what does that mean? It means that this quadratic trinomial here is prime. It cannot be factored. So we're going to reinsert this factored form into the problem exactly as it is, alright? So let's put it back. So we're going to have 2x to the 2nd power times x squared minus 2x plus 4. Okay? Alright, now that we have everything factored, we're going to multiply across. If we multiply across, if you multiply in fractions, remember the rule is you multiply the numerators and then the denominators, alright? So multiply the numerators and preserve the factored state. We're going to have x times x minus 2 times x plus 2 times x squared minus 2x plus 4. Okay? That's the numerator on the left and the right, factored. And then in the denominator, we're just going to multiply across also. So we're going to have x minus 2 times x plus 2, and then we have 2x squared. We can put the 2x squared in front. It doesn't really matter. 2x squared times x squared minus 2x plus 4. Okay? So remember that multiplication commute. So the order that you write these factors does not really matter since we're just multiplying them across. Alright? So that goes the factored form. So let's see what we can cancel out here. What's common in the numerator and the denominator? So we have x squared, x minus 2 goes in here once, and x minus 2 goes here once. X plus 2 goes here once. X plus 2 goes here once. And notice that these two quadratic trinomials are actually identical. So x squared minus 2x plus 4 goes here once, and x squared minus 2x plus 4 goes here once. Okay? So we are left with x over, how about we break this down? 2 times x times x. Can I reduce this? Absolutely, right? X goes into the numerator once, and then x goes here once. So our final result is 1 over 2x. So that's a factored form. That's a simplified form of the original problem that we had. Okay, so we can go ahead and box our answer because our work is done. Thanks so much for taking the time to watch this presentation. Feel free to subscribe to my channel. Please post a comment to let me know what you think about this clip, and you can always click like if you liked it. Feel free to share it with your friends via your respective social networking programs. Thanks again for watching, and have a wonderful day.